Welcome back to Python 4. Today we're covering the basics of graph plotting. Let's get into Jupyter Labs and begin. Here we are. Today we're going to be covering basic graphing, some graphing functions, and also CSV readers as well. So let's just get everything out of the way and jump straight into making a graph. Here's the code to just make a graph, and no more. But you will need more, so we'll be back later. Here we are, import matplotlib, importing, make some dummy data, put it into plot, put it into scatter, show our graph. There it is. There's your graph. What do you mean that's not enough? Fine. Let's explain what's going on, and we'll see how to use a CSV reader from Pandas to graph our Excel data from the previous video. If you remember, we brought our CSV file in. Here it is up here. This is our CSV file that we're going to be using today to make a graph. So, to explain each line of code here and what's going on and how to make a graph, first we import the matplotlib library for graphing. I've then created some dummy data for us to use. So we've used our lists as inputs here. We've put our lists into plot.plot in the order x and y as well, so make sure you get it around the right way. It's the x values first, and then the y values, okay? So we've put them in, and then we've done plot.show, and that displays all of the graphing functions that we've executed so far. And in Jupyter Labs, the graph is just outputted down the bottom. So here it is here, this is our graph. As you can see, exponentially increasing all the way up. So now we're going to move on to the functions, understand, I've just explained this. This has just been explained. But this is the difference between them. You might be wondering, what does plot do and what does scatter do? Well, here's scatter just by itself. There it is. Can you see what it did? It made a scatter graph of points, just individual data points placed on the graph. However, plot.plot, that gives you just the line that connects the dots, but it doesn't show you the data points themselves. So these things seem okay, but by themselves, they're kind of missing something in each of them. This one doesn't have a line that connects the dots. This one doesn't even have the dots. If only we could combine them. Well, we can. We can combine them. Down here, when you do plot.plot and plot.scatter before doing plot.show, so you've done those two functions first together, and then you show your graph. Ta-da! We have our graph that contains both the scatter graph and the plot graph as well, all in one. So we've got the dots linked up, and we can see our data points as well, nice and clear. Just to go over the plot.show function as well, this will display whatever commands have come before it. If we have two commands to make a graph, but only one plot.show function, then these two commands will be shown on a single graph, like what we've got down here. So this is all well and good, but first, you might be wondering how we get our data into some usable form. So to do that, we use Pandas and CSV readers as well. So now we're going to introduce the Pandas library and a new function called pandas.read_CSV. And the input to this function is the file name as a string, okay? The readCSV function returns a data structure object that will be assigned to a variable, okay? The data structure resembles a list of lists containing the data from Excel. However, Pandas labels the lists using the column heading from Excel for easier indexing in Python. Okay, just to show you what that looks like, what's going on here is that I've imported Pandas as PD. I've read in the CSV file, okay? I've typed in, if you go up here, see up here, it says Excel_gravity_CSV.CSV. I've entered that file name in as a string exactly as it is. It needs to be exactly how it says, okay? Otherwise, it's not going to work. And we've assigned the read CSV, the return value is an object, the read CSV object, into our data set. And then I've got a normal list to compare, okay? And now I've got some print statements which are going to display the things. So up here is our normal list. This is what a normal list looks like. And down here is the read CSV object that's returned, okay? So you will notice a few things. On the right here, we've got the values listed down the ways. And on the left, we've got their positions as well. So number 5 is position number 1. Well, position number 0, but it's the first position. See how easy it is to get mixed up, even just trying to communicate it. It's very easy. So make sure it's the first entry, but it's the 0th position, okay? And it gives us the name and the data type as well. So the data type is integers, 64-bit integers. So it can store up to 64 bits. And the name is mass kilograms, okay? So what you get here in the name is what we will use to index this read CSV object later, okay? And below it, we've got the other data set for weight in newtons. So the name is weight, newtons. The data type is a float, 64-bit float, because you can see it's got these points. The decimal points mean it's a float number. So we can see the difference between the read CSV object and a normal list. The object is easier for us to index, however, as we've made the names for each columns ourselves. We can have as many columns as we like in a CSV file, as long as they're named in the top row, okay? So refer back to Excel to get your column names, and the read CSV object acts just like a list that we can input into plot and scatter to make our graph, okay? Just to show you about the names of the columns, we go into the CSV file up here, and these are the names that we're going to refer to, okay? This is what we'll use to index this column, and this is what we'll use to index this column, okay? So, really important note here. In physics, we do not join the dots. We don't join the dots. We use a line of best fit to show the trends and correlations in our data. Due to this, you will not be using plot in laboratories. Instead, you will use scatter. And we'll learn how to draw a line of best fit as well in a future video to go through your data when you're creating your graph. And this will be covered in Python 6, I believe. It's Python 6. So, some graph etiquette here. I've mentioned independent and dependent variables last time in the Excel segment of the video. So, in scientific research, we get to be very independent. For example, independently choosing what variables to change in our scientific experiments. We give those variables, say, mass, height, power, that we can change a special name. We call them the independent variables. The independent variables is the first thing we can control in our experiment, and not so coincidentally is the first thing we put on our graph on the x-axis, okay? We put independent variables on the x-axis. Horizontal axis for independent variables that we choose. So the results that we measure are dependent on what we have changed each time. We call the results that we measure the dependent variable, and they are graphed on the y-axis. So the independent variable is the thing we control in an experiment, and it's graphed on the x-axis. In this experiment, in the Excel example, it's mass in kilograms because I've chosen what mass to put on. So that's the independent variable. The dependent variable are the results that we record from the experiment. So they are graphed on the y-axis, and in the Excel example, it's the force. I've measured the force from the spring balance, and that is the dependent variable. Okay, that's the graph etiquette out the way. We know what to graph on the x-axis, the independent variable that we control. On the y-axis, the dependent variable that we measure. And now we're going to go on to plotting with pandas. So let's use our read CSV function object, the function object that's returned, so that's a data structure, to plot a scatter graph with our independent and dependent variables on the correct axis. So we're importing matplotlib, and then we're importing pandas, and we're using our referencing names as well. And then we are assigning the read CSV object to our dataset, and then we're using indexing, okay, in the plot.scatter function. So it's x first and then y. On the x-axis, we have our independent variable. That's mass in this example, so I've used the column name from up here, okay, mass kilograms, exactly as it is, as a string, and here to index, and then our dataset is the dependent variable on the y-axis. And again, reference on the Excel and the CSV file, weight, put it in as a string, all good. Plot.show to display the graph. There it is, our first graph. This is our data. It's a wee bit wobbly at points, and some of it's kind of not quite right, but that's what you expect from experimental data. You expect that. Sometimes it goes horribly wrong, sometimes it goes great. Man, it's amazing when it goes great. But when you look at this graph, it's incomplete. It's an incomplete graph. We're missing a few things. we still got to have a main title, an axis title in units, a line of best fit, grid lines as well, and what about a bigger graph? I mean, it's pretty small, right? We need to change the figure size. And how do I save a copy of my graph? I really like it. How do I save it? So we've got functions for these as well. So to explain the functions, I will use this layout here that I've said. We've got the function name in bold, and then the parameters listed out in order. The parameter name, and then the type of data that goes into that parameter. And then what the input parameter should be will go here. And then the next parameter, and so on and so forth. And then what the function is used for, okay? So a practical example will be shown at the end to demonstrate how to use the functions. Okay, it'll be one big example, and I'll go through it and explain each one. So let's get into the list. Further graphing functions. First one is plot.figure, and then we've got this variable fig size is equal to, and we use a tuple. Remember I mentioned tuples for dimensions. In this case, it's the dimension of your graph. We've got the x-axis first, and then the y-axis, the size of it. So fig size, the type that we input is a tuple. Fig size takes a tuple xy, specifying the dimensions of the x-axis first, and then the y-axis. The units are unit inches. These are not an SI unit. They're defined as 80 pixels by 80 pixels. So plot.figure allows you to change the figure size of your graph using the parameter fig size. Number two is plot.title. It takes a parameter label, which is a string. This label as a string is the name of your main title, okay, of your graph. And it allows you to title your whole graph using the parameter label. Number three is xlabel. This allows you to label your x-axis with the parameter xlabel as a string. Number four is ylabel. Again, you can label your y-axis as a string just by inputting it as ylabel in here. Number five is plot.grid. So visible, that's one parameter. The type is a Boolean, so true or false, that's what a Boolean is. That indicates whether to show the grid lines or not. So if it's true, it will show the grid lines. If it's false, it won't. Or you can just leave it out and it also won't show the grid lines. We always want to show our grid lines though. We always want to show them. And there's also the parameter which as well, which is basically which type of grid line do we want? Do we want the major grid lines, the minor grid lines, or both? Most of the time we're going to use either major or both. So that's that. Another one to follow on from plot.grid is plot.minor ticks on. Okay, this is a requirement. It's a requirement to show the minor grid lines on your graph. Okay, it's a requirement. Number 7 is plot.savefig. Yes, I can save my graph. So you put in the file name that you want to save your image as. It'll save it as a PNG. Okay, the name can be whatever you choose. The image file is saved in the same folder in the notebook over here. Okay, so that plot.savefig allows you to save the current figure using the parameter fname as a string. Okay. Number 8 is plot.show. We've already seen this. It displays all open figures. This means all functions related to graphing that haven't been shown yet. Okie doke. That's a list of new functions. Now it's the example. This is using them all together. Attention, while this code looks like a lot, consider that half of it is comments before making a judgment, okay? A clean version of the code will also be shown at the end. So let's get into this. First, import our libraries, then read in our CSV file using the pandas.readCSV and assign it to your dataset variable. And then we're going to change the figure size using plot.figure. I've made it 14 by 8, okay? So this is changing it to be 14 wide and 8 high, unit pixels, but you just kind of eyeball it every time and see, does that look strange, right? Next up, we label the x-axis with a name and the units, kilograms, the y-axis with the weight and the units as well, newtons, and then the title. We're just going to call it weight over mass because that's what it is. And then we're going to plot the grid, but we want to plot both axes, so we need to turn our minor ticks on. So it's just this function here, no parameters, just close brackets, and it'll do it automatically. Then plot.grid, we want it to be true. We want to show our grid lines, and we want to show both big ones and the tiny minor ones as well. And then it's actually plotting the scatter graph, okay? So we take in our data set and we use the title names for the x-axis, okay? This is the independent variable on the x-axis, mass. and then the y-axis next, the dependent variable weight. Just like that, this makes a scatter graph. And then we're going to save the fig before showing it. We're going to save it as weight over mass.png, and then we're going to show it. Let's execute this. Yes, it worked. We've got our title up here, our grid lines, minor and major. We've got a title for our y-axis, a title for our x-axis, and it's a scatter graph as well. And over here, we've got our weight over mass. Here is our PNG. So to save this, where is it? Just download, save it as a computer file, and then you can use it in your report, whatever it is you're writing up on Word or LaTeX. We would suggest LaTeX for practice, but at the beginning, just whatever you can use. But as you get later on into university, you'll be using LaTeX for official reports and things like your thesis, stuff like that. So best to practice early. All right, that's this video covered. We've covered all the new functions. We've covered basic graphing. The next video we're going to go over is arrays, and later on we're covering lines of best fit. Okay, that's going to be a straight line that goes through these points and is optimally placed between them, and also finding the gradient as well and why that's useful. So we'll also examine a concept that will appear throughout your experimental physics career, and we'll finally link our physics laboratories and our theoretical knowledge together. Okay. Thanks for watching. Before I go, here's the clean version of the code. As you can see, it's not very much. Without the comments, it's very clear to see there's not that many functions. We've had about 4 videos to lead up to this. This is where we are just now. This is the end of the basic stuff. We're going to get into more complicated graphing from this point onwards. And then afterwards, we'll take a wee dip into basic statistics. And then again, it'll hype up. Just climb up and then complexity. But don't worry, it will be done gradually and you will understand everything as you go along. Feel free to watch these videos again as many times as you need. And also have Jupyter notebooks open as well as you're going through them. And maybe type a few things, try things out as you're going through. I find that really helps me when I'm learning new things, and it will probably help you as well. Thanks for watching, and I will see you in the next video. Bye.